Hi, my name's Jeremy, and we're going to learn some Python. We're going to use the program is Python Online Compiler here. So you can chuck that into Google, and it'll be your first link. So something you might expect to see in any intro to programming tutorial is hello world. So what are we doing here? We're telling Python to print the string hello world. Print's just an inbuilt function. This here is a comment. It starts with a hash, so it just reminds us what we're doing in the program. It can equally not be there. We could take this string and store it as a variable and print A. So here we're telling Python store hello world as A and then print A. We can do this, add two strings together. So have a pause here, have a think what's going to happen when we click run. We're missing a space, so we can put it in here. We can equally store the output of that as another variable and print C. We got an error here. Python uses indents, as we'll see later, to mark code blocks. So if you ever see unexpected indent, just check for a space before a line of code. So we've stored A plus space plus B as C. A is hello, B is world, so C is going to be hello space world. So another thing that we can do with variables is reuse them. Feel free to pause and type this into your compiler. So here we've said name equals John, print hello name. Name equals Bob, print hello name. Name equals Sally, print hello name. We can do different things with them each time. So anything we put in here, Python's going to pass through to this built-in function, and it's going to print it. You can store numbers. So A equals 5, print A, that'll print 5. If we print A plus 1, we'll get 6. And you can use pretty much all of the mathematical operators you expect here. If we change A, all of those outputs are going to change. So we could have two variables. Print A minus B, A plus B, A divided by B. And we get out exactly what we expect, 2, 8, and 1 2/3. There's another interesting mathematical operator that we're going to use later when we're talking about prime numbers, which is this modulo or modulus operator. So what this says is divide A by B and tell me what the remainder is. So this is saying divide 5 by 3, it goes once, and tell me what the remainder is. You've got 2 remaining after that, so that's the output. Remember that one, it'll come up later. So these are integers. They don't have anything after the decimal point. They're whole numbers, so we call them integers. We can also use what we call floating point numbers, and they work pretty much exactly the same way. And the modulo operator. In Python, you don't have to worry too much about whether your numbers are integers or floating points. It tends to handle everything pretty similar. Another interesting concept is process flow. So we've got this if statement here. So if A is greater than B, we've got A equals 1, B equals 3. So if 1 is greater than 3, it's not going to print this. Else, it'll print this instead because 1 isn't greater than 3. So we can see A equals 1, B equals 3, B is bigger. If we change A to be bigger than B, it'll print A is bigger. We could store the output as a new variable. So A equals 1, B equals 3. But when we try and print it out, Python gives us an error, and it gives us an error for an interesting reason. It says can only concatenate string and string. Concatenate just means add two strings together. So we've told Python to add a string and a number. So all we have to do is tell it explicitly that we want the string of C. So here it says the bigger number is 3. Again, if we change that to 8, it'll say the bigger number is 8. So when you get an error, just have a read, see what it's telling you. If you need to, you can just paste this into Google and see what happens. You'll get a very, very quick answer for that one, because it happens to everyone every day. There's another way to do this, which is a lot easier, which is we can use the built-in function max. Python has a lot of fun built-in functions to help us do some simple stuff. That is numbers and strings. You've also got lists. So a list is denoted by these square brackets, and lists have elements. Here we've got 1, 2, 3, 4, 5. And we can ask for the max of the list. We can ask for the min of the list and the sum of the list. And we'll get our answers. So 1 plus 2 plus 3 plus 4 plus 5 equals 15. One that you'll find yourself using a lot is the length of the list. So here we can see we've got 5 elements in our list. If we want to get the first one, then something like this may look like it would work. So we ask for 1, but instead of getting the first element, we're getting the second. That's because lists in Python, like in most languages, are indexed from 0. There's a really good reason for that. It has to do with how the computers actually store the lists on the inside, or how they used to. But just remember, if you want the first element of your list, you'll have to ask for the 0th element. So we can also store that as a variable and just pluck a number out of the list and print it. Our last element is going to be at 4, because we know if our, in this case it's going to be 5. Let's print out the length of the list just to confirm. So we're length 6, 1, 2, 3, 4, 5, 6. But we know the first element is 0. So if we try and print out the 6th element of the list, it's not there. So just remember that your last element is at len minus 1. We can print out slices of our list. Sorry, that should be a colon. And a slice just takes a chunk of the list. So here we're starting at index 1, and we're going to index 4. It'll actually give us the one before it. So we're going for 1, 2, and 3. You can equally say, give me all of the ones up to index 4. Or give me all of the ones starting from index 2. You can change an element of a list. So the same way we indexed it before, lst0 equals 10, and we'll print out the list. And we can see here we've changed the 10th element of the list. You can append to a list. Append just means add on to the end. Here you can see we've added 6 and 7 to the end. You can define a new list. And you might try and append that to the end of your list, but something weird's going to happen when we try. You can see instead of 6, 7, 8 here, we have these square brackets, which means that we've actually added a list onto the end of our list. So let's take a look at what the length of the list is. We'll take a look at our last element, which is going to be at length minus 1, which is 6. And we can see that all of 6, 7, 8 is there. So if you want to add the elements of a list onto another one, you use the keyword extend instead of append. So that will take the contents of our new list and just add it on to the end. So here we can see 678 at the end, just like we expect. That's lists. There's another interesting variable type called a dictionary. So dictionaries have keys and they have values. Dictionaries are denoted by these squiggly brackets. So we have a name, which is Joe. We have an age, which is 32. We have a hair color, which is brown. We index them in similar ways to a list, so we just put it in the square brackets. So Joe's name is Joe. Joe's age is 32. And Joe's hair color is brown. We can set these, so we can say, hey, hang on a second. Joe likes to be called Joseph. And when we take a look at our object, we can see that Joe's name has changed to Joseph. So that's strings, numbers, lists, and dictionaries. What we're going to do next is take a look at some functions and some loops and see what we can do with these variables.